Okay, it's Thursday night, 9:57 on the 24th of July, 2025. We're looking at the region of the sky that should include the dumbbell planetary. We're not seeing it, just like we didn't see it last night. Operating at about 90x. I've been refining my magnifications for quite a while now. Anyway, we're looking through the f8 ED150, which typically has twice the magnification as the El Quattro, the f4, not using any kind of reducing Barlow. This is typically about 15 magnifications higher than the Rev 2 system, which usually operated about 75x, has a field of view of about 35 by 35 arc minutes in size, and I fitted the moon in. Right now we're operating at 32% zoom. Sometimes they see it go down to 28, but it's 32 now. Let's run her up a little bit to 50% zoom. We're still not seeing. The dumbbell planetary, we're operating at 0.2 seconds. This is the same result I got this time last evening using the Nebula enhancing filter. At 0.5 seconds exposure time, we're just beginning to see the brightest aspects of the dumbbell planetary here. I could play with the histogram, but won't. Let's push it up to 50% zoom, and we're starting to make out a bit more. If we go to 100% zoom, where presumably get that, all the pixels are in use. Seeing a little fuzz around the stars, it was kind of hard to get the focus back again. These magnifications tend to be a bit difficult on focus anyway. So we're currently operating at what I consider to be roughly 300x, dropping back down to 150, which is my usual zoom. We can see the dumbbell shape forming at 0.5 seconds. Exposure time. The sky is now almost losing its color. I would say we're close to sky dark. All right, this is the 30-second view of the dumbbell. It looks spectacular. Look at all the stars. Without a nebula filter, we're not repressing the stars. That was a second pass. I should play with the histogram a little bit to improve the image quality. That is superb. I would guesstimate that I'm going to take some region of this screen, for instance, and then count how many stars are in it compared to previously with the Nebula booster. And I'll bet you we're getting anywhere from 4 to 8 times as many stars per volume as we got there, which means we're adding at least 2 to possibly 3 magnitudes in depth and possibly even more. There were no other stars collined with the dumbbell planetary, and in fact, the central star of magnitude 14.1, some say 13.5, was barely visible. This is a spectacular view. I think we should go on to the crescent before we begin our adventitious studies of the evening. Okay, folks. The nebula filter, I was suspect about it all along. We're getting as good a view of the crescent nebula, if not even better, at 30 seconds exposure as we were getting with the nebula filter in place, the nebula booster. I don't think I'll really be using that again. I'm going to play with the, oh, look at that. That is just spectacular. Playing with the, at 30 seconds exposure, I'm adjusting the histogram, massive numbers of stars. I would probably say more than 8 times, maybe even 16 times as many stars visible in the field. This bodes well for when we go to galaxies later on in the evening. And the Crescent Nebula just simply looks spectacular without the nebula filter. Not sure I'll ever put that thing to use again, except perhaps for eyepiece use. Moving on. Well, I must say this is rather conclusive. Look at the Eagle Nebula. NGC 6611. It is more present without the filter than it was with it. It's a nebula in open cluster, and look at the population of cluster stars in Serpens. It's also known as Messier 16, magnitude 6, 7 arc minutes in size, 60 stars. That's the open cluster, not the nebulosity. It's a class 2-3 open cluster, 5,800 light years distant. Right ascension, 18 hours, 18 minutes, 48 seconds, with a declination of minus 13, 48, 24. A spectacular, high contrast view populated by innumerable stars across the field of view and very easily adjusted in terms of the histogram. Very nice. No nebula booster. Okay, we're not expecting to see much here initially. This is NGC 6612, Galaxy in Lyra. Magnitude 15.5, 0.7 by 0.7 arc minutes. It's a compact galaxy. I had to do quite a bit of change in terms of the histogram for this. We're at right ascension, 18 hours, 16 minutes, 10 seconds, with a declination of plus 36 degrees, 4 minutes, 42 seconds. We're looking for a fainty here. And let's see what we get when we zoom in. I'm kind of seeing a faint galaxy with a core and extensions. It looks kind of edgy on rather than being 0.7 by 0.7 arc minutes. But I suspect this is our candidate. I'm going to go ahead and do a bit more zoomage on it. Center it up in the field and go to 300x. Not a particularly attractive field, but we are seeing something that looks like a galaxy here and a more edge-on galaxy there. Remember, this is magnitude 15.5, dropping back to a much better looking 50% or 150x. Here we see our galaxy in the field. Several galaxies in the field, this edgy on, this fainter one here, and possibly an even fainter galaxy at this location. Okay, I thought we'd have a look at an open cluster. This is NGC 6613, open cluster in Sagittarius. It's also Messier 18. Magnitude 6.9, 9 arc minutes in apparent size, 20 stars, brightest of which are 8.6. And look how brilliant they look on the screen. Right ascension, 18 hours, 19 minutes, 58 seconds, with a declination of minus 17 degrees, 6 minutes, and 7 seconds. I did have to adjust the histogram to compensate for this being further south in the sky, as well as being an open cluster. Our next view, of course, is the Swan Nebula. The color is a little different than when we reused the filter, but I suspect we're getting a very comparable view. Perhaps even more contrast and more delicate detail. NGC 6618, Nebula in open cluster in Sagittarius, also Messier 17, 6 magnitude, 11 arc minutes in size, as for the cluster, and 40 stars, brightest of which are magnitude 9.3. It's a class 3-3, so stellar magnitudes are very disparate and they are widespread. 4,200 light years distant. Right ascension is 18 hours, 20 minutes, 47 seconds, with a declination of minus 16 degrees, 10 minutes, and 18 seconds. The Rev 2 could never get a comparable view. And I typically used it at 2.5 to 5 seconds exposure time, which probably would be a good tech check right now. Let's go down to a 5-second exposure. Okay, check it out, the Swan Nebula at 5 seconds exposure. The Swan at 2 seconds exposure. Okay, here is where I think the nebula filter worked best. Can you find a planetary nebula amongst this field of view? If you did, it would be NGC 6620, Planetary in Sagittarius, magnitude 14, 5 by 4 arc seconds in size, with a magnitude 16 central star. Here's where the problem comes up with planetaries. The central stars can overpower the actual planetary nebula itself. This is a very distant planetary, 28,800 light years, It's a declination of minus 26 degrees 49 seconds. That 28,000 light years pretty much puts it very close to the line that we would draw through our Milky Way galaxy, and it would be on the far side. Let's run the magnification up to 300x. See if we have any luck whatsoever in picking this baby out. Couldn't tell you where it's at. Okay, here we have a globular cluster that eluded Messier machine. NGC 6624, globular cluster Sagittarius, magnitude 7.6. Some of the Messier globulars are down to about magnitude 8.5. This one's 5.9 arc minutes in size. Its stars are magnitude 13.8. If you subtract a 7.6 from it, you get about 6.2. 6 magnitude differentials are typically class 4s, but this one's a class 6 at 26,000 light years distant. We're seeing at a right ascension 18 hours 23 minutes 40 seconds with a declination of minus 30 degrees 21 minutes and 40 seconds during multiple stacks of a 5-second exposure. All right, here we're getting a 5-second exposure of NGC 6629, Planetary Nebula. And I failed. Look for it while I put 6629 into the handset and call it up. Have a look around, see if you can pick it out. It's a moderately sized one. 6629's in Sagittarius bright, magnitude 10.5, 16 by 14 arc seconds. It's got a magnitude 12.9 central star, 7,700 light years distant. Right ascension is 18 hours 25 minutes 42 seconds and a declination of minus 23 degrees 12 minutes 9 seconds. We are learning here and now that the reason you want a nebula filter is so you can distinguish planetaries from the rich star fields in which they may reside. What you're seeing here is one of the reasons you want a histogram setting, because we are getting a lot of off-axis light with the scope tilted down to minus 25 degrees 29 minutes and 55 seconds. Right ascension 18 hours 30 minutes 56 seconds to capture NGC 6638, globular cluster in Sagittarius. We'll push the magnification up a little bit. It's magnitude 9.2, very small, 2.2 arc minutes. Brightest stars are magnitude 15, and we are resolving a lot of them. As I've already quoted, right ascension 18:30:56, declination minus 25:29:55. Okay, rivaling Messier 13 is NGC 6656, a globular cluster in Sagittarius. Excuse me, it's also known as Messier 22, magnitude 5.2, a little brighter, 24 arc minutes in size, a little larger. And its brightest stars are magnitude 10.7. It's a class 7, 10,000 light years distant, so it's 2 to 3 times as close. Right ascension is 18 hours 36 minutes 24 seconds with a declination of minus 23 degrees 54 minutes 17 seconds. We can do a bit of a zoom in. I can reposition on the screen slightly, and there is our view of Messier 22. What we're seeing here is a couple of NGC galaxies, both edge-on presentations. Hoping I remember the designations. Should be NGC 6658, probably this one right there. We do a bit of zoomage on it. And back it out to 150x. NGC 6658, Galaxy and Hercules, magnitude 12.9. Nice aspect ratio, 1.6 to 0.3, so about 5 to 1. Spiral, the lowercase a, 196 million light years distant, puts this one about 75,000 light years in diameter. We're at right ascension, 18 hours, 33 minutes, 55 seconds, with a declination of plus 22 degrees, 53 minutes, 16 seconds. Nice to see those wispy, spiraling arms, isn't it? NGC 6674 is there on the screen for you. Supposed to be one of the largest 12th magnitude galaxies that I'm aware of. I'll give you the data on it here as soon as it comes up. We'll do a little bit of a zoom in. NGC 6674 is a galaxy in Hercules, magnitude 12.2, but 4.2 by 2.1 arc minutes. Spiral with a bar, lowercase b, which means it has two spiral arms, twice removed from the lenticular. 157 million light years puts this baby at somewhere around 157 million light years puts this at about 175,000 light years in diameter. We're getting a little bit of a spotty view here. I can play with the histogram, bring it out a little bit better, and there we have it. NGC 6674. I am about to save this first 16 minutes of the video. Hopefully it will not be truncated. Okay, part 2 of our evening studies, and this previous galaxy here, which I forget the designation, I think it was 6695 or thereabouts, has now had a multiplicity of 10-second exposure passes, which is bringing out its angularity quite visibly on the screen. Okay, so we got about another 10 minutes of imaging that we can do, real-time imaging. So let's continue through 6700 series now and pick out some special studies to view. All I've learned now from using the unit, the filter unit, was that it's really good for planetary nebula, but not much else. And that would be my current characterization of the planetary nebula we used over the last 5 or 6 videos in this series. Okay, you all know what we're seeing here. Ring Nebula, and by Messier 57 of 110 on its list. This is NGC 6720 by another name, the Ring Nebula. Magnitude 9.4, 86 by 62 arc seconds in size. The central star in this database is magnitude 15.8. It is quite present on the screen, as well as its 13.1 magnitude line of sight neighbor. 2,900 light years distant, with a right ascension of 18 hours, 53 minutes, 35 seconds, and a declination of plus 33 degrees, 1 minute and 44 seconds. Let's push this one a little bit. Seeing a second star right inside of it. I didn't even know that there was a second star. Very, very nice. Okay, I bumped the exposure time up to 30 seconds. And we're looking for NGC 6740 galaxy in Lyra, magnitude 15, 0.9 by 0.8 arc minutes. Spiral with a lowercase b, multiple spiral arms, and a ring. And we're at 30 seconds exposure time. And guess what? That ring is obvious. Not a good look at 300x, but let's drop it back down to 150. And there we have our annulus around NGC 6740. 200 million light years distant puts it at about 40,000 light years in diameter. Right ascension is 19 hours, 50 seconds, with a declination of plus 28 degrees, 46 minutes, 15 seconds. 30 seconds of exposure time. Wow. 15th magnitude galaxy, and we're seeing the ring. Typically 13.5s and lower settings is all you're going to see an angularity around. We've added a 1.5 magnitudes to our angular reach by using 30-second exposure times. Well, this should be our last planetary nebula of the evening. This is NGC 6765 in Lyra, Magnitude 12.9, 38 arc seconds in size with a magnitude 16 central star, 7,600 light years distant. We're at right ascension 19 hours, 11 minutes, 6 seconds, and a declination of plus 30 degrees, 32 minutes, 44 seconds. I do believe we're seeing the planetary right about here. Doesn't seem to be that much distension of the stars. We're supposed to be seeing a 16th magnitude central star, and I do believe it's right there, if I am not mistaken. Oh joy, this is the Western Veil, and frankly, we're getting a higher contrast view than we did with the Nebula filter the previous night. Of course, I can make it all disappear with the histogram. Very nice view. We're seeing the nebulosity above. I believe this is 52 Cygni. We're certainly seeing the witch's broom here, plus extension with all kinds of delicate detail heading off to what I believe to be the north of the 4.8 magnitude star. I can, of course, play with the histogram to improve the aesthetics. And I think this is probably quite a good view right there. Let's go ahead and tour the rest of the supernova remnant. Remember, this supernova occurred about 10 to 20,000 years ago. It's 1.5 K light years distant, and it was a star of a mass equivalent to 20 suns, which is very similar to Deneb, which could go in the next 1 to 2 million years itself. One thing we're missing here without the filter is we are not getting the delicate color information. Here we are just vaguely making out, just like we did the other evening, the more northwestern part of the Veil complex. NGC 6974 in Cygnus, of course, 1,500 light years distant, no sense of magnitude, probably somewhere around magnitude 16. Right ascension, 20 hours, 51 minutes, 4 seconds, with a declination of plus 31 degrees, 49 minutes, 42 seconds, and probably not more than 2 by 2 arc minutes of distribution in space. I could play with the histogram a little bit to see if we can bring it out. There's nothing I seem to be able to do to improve on that. Ooh, that's aesthetically a better view, however. Let's go on to another part of the Veil Nebula. Well, I have to say, I thought we made out a little bit of the NGC 6979 Veil, the northeasternmost component of the Veil. 3 by 2 arc minutes in size, 1,500 light years distant, of course. Right ascension, 20 hours, 50 minutes, 28 seconds, with a declination of plus 32 degrees, 1 minute and 36 seconds. I'm going to allow it to make a second pass, and it's going to finish it up in about 5, 4, 3, 2, 1 seconds. But no, we are not detecting any more of the veil than we've already want to see, which I did see a little bit of last night using a nebula filter. Okay, this is the NGC 6992 component of the Veil, supernova remnant, and Cygnus. Magnitude 760 by 8 arc minutes in size, 1,500 light years distant. Light ascension is 20 hours, 56 minutes, 19 seconds, with a declination of plus 31 degrees, 44 minutes, 36 seconds. And I'd like to say what I said in captioning the previous evening's video, and that is, if you really want to see the Veil complex, get a nice 4-inch fast 4-inch refractor, use an eyepiece at 25x and a nebula filter, and you should almost be able to encompass every aspect from the witch's broom through this final segment, which I am about to navigate to, and we'll have a look at on the screen. Here's our final view of the Veil complex, NGC 6995 in Cygnus. It's magnitude 7, 12 arc minutes in size, 1,500 light years distant like the rest of it. Right ascension 20 hours, 57 minutes, 10 seconds with a declination of plus 31 degrees, 13 minutes and 6 seconds. This is the easternmost portion of the Veil, and it approximates in declination to the westernmost part. And between 60, I believe it was 91, 95, and 60, that these are the three brightest components of the Veil that can be tracked down with normal eyepiece observing and including a nebula filter, which is very helpful for the eye, but may not necessarily be useful or necessary when you're using an real-time imaging stacking system, such as the Z1 Pro. As the scope slews to what may be our final study, I thought I'd show you the luminosity associated with NGC 7000 in North American Nebula. Very difficult to pick out because we don't have a large enough field of view and no sense of contrast with any part of that field of view. Okay, what we're seeing here as our final view of the evening is a very distant and faint globular cluster. You can look at it here, you can see that it is clearly a highly condensed globular. It's a class 1. It is magnitude 10.6, and its brightest stars are 15.6, which is very peculiar because the difference in magnitude is only 5, and typically you get closer to 7 when you have a compact globular cluster. But apparently this one does not have many stars. It's 133,000 light years distant, so lies outside the bounds of our Milky Way galaxy. It is at right ascension 21 hours, 1 minute, 29 seconds, and plus 16 degrees, 11 minutes, 14 seconds. And I thought I'd throw this in for you as a potential ending of the evening. And I think since we're now at 10 minutes and 53 seconds in the final segment of this video, that's exactly where we shall leave. Carpe Noctem.